Welcome back, everybody. This is our video solution to problem 5 from Quiz 7, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. All right, let's see. We have a vector space V over a field F and a linear operator T on V. We want to prove that if T has dimension of V distinct eigenvalues, then T is diagonalizable. All right, so this relies on a result we showed, which is that if... So there's a fact here that we proved. If, say, V1 through Vn are in V are eigenvectors corresponding to distinct eigenvalues. Okay, so each one of these V1 through Vn corresponds to a different eigenvalue. Then the list V1 through Vn is linearly independent. Okay? Now, we're assuming here that T has dim V distinct eigenvalues. All right, so our list really looks like V1 through V dim V. All right, and this is now going to be some linearly independent list. But if you have a linearly independent list whose length equals the dimension, which this one does, then it must be a basis, because we know every linearly independent list can be extended to a basis, but this already has the length of a basis. So this implies, right, that this list V1 through V dim V is a basis of V. Now, each one of these corresponds to some eigenvalue. Let's say this V1 corresponds to a lambda 1, so forth, lambda dim V. All right, and so now what would be the matrix of T with respect to this particular basis, right? This, by the way, is an eigenbasis because it's a basis of eigenvectors. So if I wanted to write down the matrix of T with respect to this basis, so I have V1 through V dim V, well, what happens when I apply T to V1? I get lambda 1 times V1. All right, TV1 is lambda 1 times V1 because V1 is an eigenvector with eigenvalue lambda 1. And so I would just have here lambda 1, 0, 0, 0. Lambda 1 times V1, and I don't need anything else. And then if we had a V2, I'd have a lambda 2 here times V2, and I get zeros everywhere else. And this just extends. And then the last one, I'll have lambda dim V with zeros up above. And so we end up with a diagonal matrix for T, and thus T is diagonalizable. Okay, so this is the big, beautiful connection here, right? If we have an eigenbasis, we get a diagonal matrix for your operator if you write your matrix in terms of that eigenbasis. And once you know that you have dim V distinct eigenvalues, you now know that you get a list of eigenvectors of length the dimension, i.e. you get an eigenbasis. Okay, everybody, we will see you next time.